All right, we're rolling. For those of you listening at home, howdy. We are going over the answers to 4B-2. I'll send you an answer key at home, y'all. So I read off most of the answers already, but we haven't gone through any problems yet. Where did I leave off? Oh yeah, number 20 I was gonna write. 20, there are two different ways to do it. Y equals -2 over x minus 3 plus -2. Or you could write it like this. Y equals -2 parentheses 1 over x minus 3 plus -2. Either way is fine. Okay. Number 21. This one was harder. And if you didn't get this one, I would not blame you. I'm actually not going to do this to you on the test. The 21 and 22 are brain teaser kind of stuff. It looks like this. Y equals negative absolute value of 1/2 parentheses x minus 1 with a plus 1 afterward. And then number 22, I'll just write it down. It's negative parentheses 2 parentheses x plus 1. Double parentheses squared plus -2. You can also do -2. Again, 21 and 22, the reason those are more difficult, they have a resize in the input. Those are actually quite challenging to do. And to do it correctly, because they mess up the order. What's a good example? If I, quick question. Let's just say I'm standing here, I am. Let's just say I go forward 2 steps and left 1. Okay, it's kind of like a chess piece. See where I ended up? Forward 2, left 1. Now pretend I go left 1 and forward 2. What do I know? Same spot. Right. Sometimes you can switch the order and it doesn't matter. Sometimes you switch the order and it matters very much. Whenever you have a resize in the input, the order starts mattering a lot. So they become very, very tricky to do as far as giving a formula or graphing it. Okay? So 21 and 22 were tough as far as that goes, but if you didn't get them, don't sweat too much. The most I would do on this is an extra credit question on the test. But these are fair game. Resize in the output should be fair game. Resize in the input, not so much. Okay? And that was it. Into repeats, first of all. All right, I'm open to questions. Yeah? 15. Let me go back up there. Got it. So g of x, which is just basically y, 15, equals negative parentheses 1/3 x squared. I did drop a hint saying this wasn't in vertex form yet. You notice the entire thing is squared. Here's what it really looks like. G of x equals, the negative stays put, 1/9 x squared. Does that make sense? 1/3 x times 1/3 x is 1/9 x squared. And if you put this in vertex form, it's negative 1/9 parentheses x minus 0 squared plus 0. In other words, the vertex is 0, 0. So if you graph this, 0, 0, it's upside down because there's a negative height multiplier. And the height multiplier is really extreme. It's 1/9 normal. So it's over 1, down 1/9. That's awfully hard to graph. You can. So like here and here. And I would not want you to do that unless you marked it. You can do that if you mark it. Like over 1, down 1/9. That's legit, but label it. If you label it, it's legal. If you don't label it, all bets are off. Over 2, normally it's down 4. Let me just show you the pattern here. Over, up. Normally it's over 1, up 1, over 2, up 4, over 3, up 9. I'm just going to go 4, 16, 5, 25, 6, 36. I normally never go that far because I don't have paper that big. But watch this. What happens with this when the height multiplier is negative 1/9? First, it's not up anymore. It's down because of the negative. Does that make sense? And then, instead of going down 1, it's down 1/9. It's 1/9 of whatever the other one was. This is 4/9. This is 9/9. This is 16/9. This is 25/9. This is 36/9. Does anybody notice if any of those are nice numbers? Go. Right. 9/9 is nice. It's what? 1. Any others? Yeah. 36/9. What's that? That's 4. So basically, over 3, down 1, over 6, down 4 are the nice jumps. You feel free to use the non-nice ones as long as you label them. You can do 4/9, 16/9. I think it's a pain in the neck, but you can. Is it legal to jump to the nice jumps? Yes. Anybody notice something they have in common, the nice jumps? They're all multiples of what? Multiples of 3. Yeah. How did that work? Look at the original problem. They're taking 1/3 of x. So chances are every third x is going to be a nice jump. If this were 1/7x, every 7th one, like 7, 14, 21 would be nice jumps. In other words, you don't have to use the nice jumps, but you can. So the graph should look like this. Really wide and kind of crushed flat and going down. Okay. So over 3 down 1, over 6 down 4, over 9 down 9, I think. Be okay with that? Next. Yeah.
13.
13, yeah. Oh yeah, that thing. Number 13, let me give you the formula. When it's cold in here, it leaves blue echoes on the screen, which is off. But I'll offer it up. So g of x equals parentheses 2, parentheses x plus 3, paren squared. It's not in vertex form yet. We've got to square this. It's 2 parentheses x plus 3 times 2 parentheses x plus 3. What you get is 4 parentheses x plus 3 squared. Does that make sense? Last week. One rule that might help, if you have a times b squared, it gives you the same as a squared, b squared. That will not work when there's a plus in between a and b. A plus b squared does not equal a squared plus b squared. That's square the first, double the product, square last. But plus signs are what destroy those. As long as it's multiplied, it should be safe. So 2 squared, and then x plus 3 squared. To fix this into vertex form, it's 4 parentheses x minus negative 3 squared plus 0. So if you want to graph it, the vertex is at negative 3 comma 0, which is over here. And the height multiplier is 4, it's not 2. So you can go over 1, up 4. That's actually the only one that'll fit on screen. On paper, I mean. If you try to go over 2, it would be up 16, which if you added a lot more paper, you could do. But that's all I really need. Does that make sense? Next. Any other ones you want to see? Now's a good time to ask. Yeah. 22. Oh yeah, one of the weird ones. Compress horizontally by a fact. Yeah, first of all, translating this in English is kind of fun. Is everybody okay with number 15? Everybody need that? Speaking hour for relative beats. And now pronounce your algebra and whatever. 22 says this, I'm starting with x squared. That's the parent graph. F of x equals x squared. Compress horizontally by a factor of 2. What in the name of all that's holy does that mean? Compress horizontally. What does that mean? Physically, what would happen? If I take something and compress it horizontally.
The graph would get smaller left to right.
Yeah, it gets thinner. Compressing horizontally is like this. Crushing it left to right, making it thinner. So in other words, compressing it horizontally by a factor of 2, what does that mean? Okay, take a stab at it. If I compress something by a factor of 2 left to right, what did I just do? Not necessarily. If I go crunch. If it's made of silly putter, I suppose it would ooze up, but what am I changing? The width or the height? The width. How? Bigger or smaller?
Small.
By how much? How big is it compared to the original? Half. By a factor of 2 means it's half as wide. That's the translated version. Half as wide. Second thing, reflect across the x-axis. Nate, what does that do if you reflect it over the x-axis? Flips it which way? Up, down, or left, right? Mm-hmm. The x-axis is this one. So if I flip it over the x-axis, it's going upside down. So the translated version is this is upside down. It's nice to be able to translate this math speak into real language. Translate right 1 unit. Translate is another word for what, apparently? Heavy. If I translate something 3 spaces to the right, that's just another way of saying to move it. Yeah. So it moves left 1 and down 2. And then move down 2. All right? See if we can do it. How do you move things? Sam.
Addition or subtraction.
Addition or subtraction. What if I want to move it left 1? How does that work?
To add 1.
Where? To the input or the output?
The input.
How do you do that? How do you make it look like input?
Parentheses.
Parentheses. Good. So I'm gonna have, you can invent any old new, don't call it f of x because it's already used. So it's something about, instead of x, it's now x plus 1. That'll handle this. How do you move it down 2? Come here, Clark.
Subtract 2.
From the input or output?
Output.
From the output. Where do I put it?
Again.
Yeah, at the end. Outside, by the way, this should be squared. Minus 2. Let's scare this. How do I make it go upside down? Mary?
You have a negative.
On the input or output?
The output.
On the output, correct. They did not resize it tall, so you don't need a number other than 1. That handles this. And then there's one more thing, which I'll probably have to erase and make a little more space. Yeah.
You just multiply by half.
Where?
Input into parentheses and
Input or output? Output would actually change the height. Input. And does input do what you expect?
negative.
Negative would make it flip. You're getting closer. Multiplying by a half, you'd expect it to get smaller, but it actually makes it get bigger. So if I want it to get smaller, I have to multiply it by 2. Here's what it looks like. I'm going to scoot this over just a little bit. What the heck am I doing? Put a 2 here, And then I want this entire thing in parentheses, because I want it in the input. Anything inside the squared is input, anything outside the squared is output. Good? And then put my negative back where it belongs. Does that make sense? Again, the resizing the input is only gonna be extra credit here. Eventually, like in calculus, it'll be a normal problem. For now, maybe even at the end of the year, I'll make it a normal problem. But for now, resizing the input is a little tough. Questions? Next. Any others you want to see? Going once? Twice? Thrice? Sold. To the people in black. All right. All right, take out your notes, please. There's not much in the way of notes, but I do want to direct you to the next homework assignment. Does everybody have the homework guide sheets? Chapter 4, chapter 5?
Somewhere.
I handed it out when I was gone. So the sub handed it out. So chapter 4 and chapter 5. People listening at home, I'll be right back. Don't worry. Just seeing if I have any extras. There's a lesson here. Anybody else? Does anybody need an extra copy of chapter 4, chapter 5? Okay. I will try and print one off. I understand the second floor copier has been choking. Maybe it's too cold. I don't know. But there's at least one. I'll print off 5 just to be on the safe side. So, pre-cal, homework. Give me a second. Sorry, people at home. I'm sure this is totally exciting to watch. Okay, 5 of these. I'm going to print them to the first floor, just because I'm feeling paranoid. Go for it. And I'll grab you one before the end of the hour. Becca, remind me if I spaz. Okay? Anyway, if anybody wants to jot down, we have done the equivalent of 4A and 4B, so we're skipping those. We did 4A-1 and 4B-2. We're looking at 4C, reflecting graphs and symmetry. So page 131, thereabouts. So if you want to follow along in your book, if you have it, yes. Hold tight, I'll send you down in just a second. You don't need it just yet. So 131-ish. There we go. Sorry, that's where the reading starts. I have a little bit new notes on this. If anybody wants to jot this down, if you don't have the worksheet, it's page 131. And I'll write down the problems on the board too. But it's 1 through 4. Problems 1 through 4. 7, 10, 12. 15. I'm debating. And I'm gonna hold off on 31 and 33. 31 and 33 I'm gonna assign for tomorrow. That's not gonna be part of today's. So if you have your worksheet out, the homework guide sheet, where it says 31 and 33, circle those and say next day or something like that. They're not gonna be for tomorrow. Let's try this. Can somebody refresh my memory? What does symmetry mean? If an object has symmetry, there's a technical term for this. Technical definition. What do you got for me? Look in your notes if you need to. Right. If it reflects, you get the exact same graph. And if it reflects, you get the exact same equation. Let's try something. I'm about to give you a relatively weird graph. Go out 3 spaces, up, down, left, right. Oops. Go ahead and sketch that in. This is in your notes, gentlemen. Go from here. This is obviously not a function. There's the graph of this totally psychotic, I'm just going to call it g of x. So what I want is reflect g of x over the line y equals x, and give me a new graph. Somebody talk me through this. I'm going to, I don't always do this, but I'm going to actually label the, we're going to pretend we're in geometry for a second. Sorry for any post-traumatic stress disorder flashbacks. I'm going to label these points A, B, C, D, E, F, G. So it's a nice rectangle A, B, C, D, a completely psychotic line segment C, E, E, F, and F, G. One trick that people use when they're graphing and reflecting or changing, the new points, you can label them like this. A, when you change it, do A with a, it's like an apostrophe. This is pronounced prime. It's actually something we use in calculus for a different reason. But A prime is like the new version of A. So A apostrophe, if you will. So in the new graph, there should be points A prime, B prime, C prime, D prime, E prime, F prime, G prime. I just want to know where they'd be. No pun intended. Okay, go ahead. Where would it, like, tell me where point A is right now, first of all. Say again?
-3, -3.
-3, -3. Where is it going to be now? The exact same point. Explain. Because not everything is. Right. Any reflection of the line y equals x, you trade the x and y. Look in your notes for that. You will need to have those reflections memorized by the time the test comes. There are 5 of them. Over the y-axis, x-axis, origin, y equals x, y equals negative x. So yeah, I'm going to mark this A prime. Can somebody tell me where B prime is going to be? Well, first of all, tell me where B is. Mary Claire, take that one. Where's B right now? -3, -2. Where's B prime? -2, -3. Correct. B prime is here. Mary, take C prime. Where is C right now? -1, -2. Where's C prime? Correct. -2, -1. There's C prime. Becca, where's D right now? -1, -3. Where's D prime? -3, -1. Correct. Because again, y equals x means you take the x and y and trade places. So far we have this. Megan, where's point E right now? 0, 1. Where's E prime? I'll have to put a dash there, but what? 1 comes 0, correct. This is E prime. Courtney, where's F right now?
2, 1.
2, 1. Where is F prime?
1,
1, 2. And Abby, where's G prime right now? Where's G right now?
2,
2, 3. Where's G prime?
3, 2.
3, 2. And so, if you notice, C connects to E, so C prime connects to E prime. E connects to F, so E prime connects to F prime. F goes to G, F prime goes to G prime, and you've just got your new graph. Does that make sense? So if I give you any sort of weird graph whatsoever, you should be able to reconstruct any reflection over x-axis, y-axis, origin, y equals x, y equals negative x. It's just a matter of use the rules on each and every point. Does that make sense? You look at that? Alrighty, let's try another one. Quick questions. Is this symmetric over the line y equals x? Josh, bless you. We just reflected over the line y equals x. Does it seem to be symmetric? No. Why would you say that?
It's not the same graph.
Right. It would have to be the exact same looking graph in order to be symmetric, and it's quite different. This was what width ways, and this is length, height ways. Things are all different. This is pointing up, this is pointing to the right. Lots of things are different. It's not symmetric over the line y equals x. Okay. Questions? All righty. I was doing this before. Quick example. Use symmetry to graph. And this is a very weird formula. Absolute value of x plus absolute value of y is equal to 1. There is no, unless you've run into this on your own, we have had no experience with this at all. First year algebra, second year algebra, and up to pre-calc, up to this point. We know what absolute value means, and we've graphed y equals absolute value of x. That's a V graph. This, well, it's not a function. How do you use symmetry to graph this thing? Well, there are 5 possible symmetries. Name them. Nick, give me one.
Like the possible y is equal to x.
That's one of them. That's number 4. Give me another one. Rainey, what's another possible symmetry for 5? They're identical to the 5 reflections. So you can reflect over the what? Like what's one line? A really easy, what? Y-axis, correct. That's number 2, or number 1, depending on your point of view. What's another one, Austin? X-axis. Number 3, go, Abby.
Over the origin.
Over the origin. And there's one more. Let me see, Nate. What's the 5th? Y equals negative x. Now the question is, can anybody just by guessing and checking give me any points whatsoever, like using a table or anything, that would actually work. Can anybody give me a value of x and a value of y that would make this true? Yeah,
X 0, X 1, and Y 0.
x is 1 and y is 0. Let's try it. Does that, everybody agree? Absolute value of 1 plus 0 is equal to 1. That works. 1, 0. That's definitely on the graph. I agree. Can we just shooting this? Yeah.
Negative 1, 0.
-1, 0. Because absolute value fixes it. Interesting. Okay. Megan, give me one. They're kind of a variation on that. Any two numbers whatsoever that add up to 1.
0.
Very good. 0, 1. That's up here. Any other ideas? Go.
Or 1/2 and 1/2.
Oh, clever. 1/2, 1/2. Now that's interesting. Do you remember the shape we had on Friday? What shape was it? Yeah, it was a circle. Does this look like a circle? This looks dented in for a circle. I'll write that down, 1/2, 1/2. That was pretty sneaky. Give me another one. Yeah.
Negative 1/2,
-1/2, -1/2. Which is here. Is anybody starting to guess what the shape might be? Keep going, keep guessing, go.
1/4 and 3/4.
Okay. 1/4, 3/4. Nice. This is here. It's getting better. By the way, I would propose 0, -1.
No, that's not.
I would also propose 1/2, -1/2. By the way, this, wait a minute, that adds up to 0. Not the absolute value first. 1/2, -1/2. What's it gonna be? With what? By the way, you didn't even touch the symmetries, by the way. Does this thing have x-axis symmetry? Just look at the picture. If you cut it across, if you flip it over the x-axis, would it be symmetric? Yes. Prove it. It looks like it. No mathematician likes that answer. Well, okay, they sort of do, but they want to prove. They said, that's nice. That satisfies the right hand, my right brain, the artistic part. Now satisfy the left brain. Prove it mathematically. Does this thing have x-axis symmetry? How do you do an x-axis reflection, Josh?
It's just the opposite of X.
That'd be for y-axis symmetry. If you want to reflect it over the x-axis, what do you do? Opposite y, correct. X-axis symmetry is check the opposite of y. What does opposite mean? Like, what's the opposite of 5? -5. What's the opposite of y? Exactly. Watch what I'm about to do. If I do the x-axis symmetry, here's the test I'm going to do. Absolute value of x plus the absolute value of the opposite of y. See what I just did? That's new. Can somebody simplify that for me? What is the absolute value of -y? It's y. So it's the absolute value of x, that didn't change, plus the absolute value of regular y. What do you notice? Compare that to the original formula. Right there. It's the same. Is it symmetric? Yes. This is the mathematical proof. Try and plug it in and see if it simplifies to the exact same thing. It did. The y-axis, by the way, will work. The origin, which is just doing both of them at the same time, will work. Let's try this one. Y equals x. How do you do y equals x? Back up. How do you test for y equals x? Again. Like, how do you reflect over the line y equals x? Check your notes if you need to. I gave you a hint. One of them's on the board.
Oh, yeah.
Yeah, switch them. There's a reflection of the line y equals x. What does that simplify to? Look carefully. What's absolute value of y plus absolute value of x? It's the same as what? Go.
X plus f, or absolute value of x plus absolute value of y.
Yeah, it's commutative. Do we have symmetric? Do we have symmetry over the line y equals x? Yes, we do. And as a matter of fact, the visuals would prove that. If you try to reflect over the line y equals x, identical. You'd never be able to tell the difference. Here's the line y equals negative x. Can somebody tell me just visually if it has symmetry? Nick?
Yes.
It does. Flip, same thing. And you could prove it. You'd have absolute value of negative y plus absolute value of negative x equals 1. It boils down to this. Perfect. Make sense? Okay, I didn't leave you a heck of a lot of time to do this, but you have the last 5 minutes to go ahead and pound away at this. Just so you know, open to page 136 if you would be so kind. This is, which, let me double check the numbers here for you. For anybody who needs to, I'm gonna run a quick run down and get you the worksheets. But this is 4 C's in Charlie. It's 1 through 4, and then 7, 10, 12, 15. That's your assignment. 1 through 4, 7, 10, 12, 15. Note number 1, 2, 3, and 4. You're gonna have to do 3 sketches of each. So they're not hard once you get the trick, but you do have to do 3 answers for number 1, 3 answers number 2, 3 graphs for number 3, 3 graphs for number 4. I'll be right back. Let me grab some worksheets. Gotcha.
More of a live magic kind of guy. Me was that really.
Got it. Who needed a copy? Worksheets, homework guide sheets? Chapter 4, chapter 5, okay. Oh, this is still going. Oh, that's awesome. For those of you watching at home, here's the worksheet, homework guide sheet, 4 or 5. If you zoom in, I'm sure you'll get it. Otherwise, I'll email it to you. Or you can grab one, or you should already have one. That should be it. So, good luck, God bless. Let me hit the correct red button. See you later.